All right, it is 12:04, so I say we go ahead and get started. How about that? All right, so welcome to how to convert a game to dots, where we're going to be talking about the data-oriented technology stack and sort of the hybrid methodologies of working with dots. So, howdy, nice to meet you. Unless we've met before, then good seeing you again. My name is Mike Geig. I'm a part of the advocacy and community team here at Unity. Cool. Now, before we begin, because I always get kind of the same questions over and over and over again. First, yes, this is being recorded and it will be made available afterwards. So you don't have to ask that question. It is being recorded. Yes, the project that I'll be showing you today is available for download. There's going to be a link here. There's going to be a bunch of links later. I highly encourage you to check out the project. We're not going to get nearly as much stuff covered as I would like to, but everything in that project, all the code's commented and everything is like explained way better in that project. So definitely feel free to grab that. And then if anyone's been around a while, you may have seen a similar talk called Converting Your Game to Dots in 2019 by me. This is an updated version of that talk with all new syntax and explanations and all that stuff because things have changed considerably since then. Cool. Now, if you have questions, I want to call out we have our chat. Our chat window is for chatting. If you have questions that you would like answered, please use the Q&A panel. We do have mods and other folks hanging out here to answer those questions. Plus, that makes it a lot easier for me to see them. Furthermore, a week from today, April 24th, we are going to be doing a live Q&A webinar, or not webinar, live Q&A stream with some Dots folks on our Twitch channel and YouTube Live. So check that out. Check that out. That's April 24th at noon Eastern time on Twitch and on YouTube. So it's going to be some fun there. So if you have questions that you feel weren't quite answered here, come hang out over in that one. We'll be doing way more questions and stuff. And we're going to have a bunch of links at the end there. Now, some of the questions I already see in the Q&A, advantages of dots, got to cover that. What are we going to be talking about? Got to cover that too. So love it. Already some great questions flowing in here. So who is this for? Now, generally speaking, this presentation, this webinar is for folks who are familiar with Unity, familiar with traditional game object workflows with Unity, and they're trying to implement dots or they're interested in implementing dots in their project. You know, they may not already be familiar with dots. You may be kind of brand new to dots, or you may have used it in the past, and you just want to learn some of the new syntax. You may, be an expert and just had a free hour and thought, well, why not? I'll just hang in here and heckle Mike in the chat. That's fine too. All right, but that's kind of like what we're looking at. And what are we going to cover? So we're going to start in the slides here with a brief explanation of dots concepts, but I'm not a big slides fan. I like to get in the editor. So we're going to get into the editor. We're going to look at how we convert game objects, how we bake game objects, how we write systems. We're going to write some stuff. We're going to create a multi-threaded job. Though, like I said, we're not going to get nearly through all the cool stuff in this project. So definitely download it, check out all that code, look at all the commenting, but we're going to cover a lot of stuff here today. So Robert's excited in chat. I'm excited too. So let's just keep going. What is DOTS? All right, so DOTS, the data-oriented technology stack. All right, so what that effectively is a series of tools, the Entity Component System, or ECS, the C# job system, and the Burst compiler. And that all sounds well and good, but you might be thinking, well, what do these do, right? Those are all just weird names. So let's do some pictures. So let's pretend this is our general game object workflow. Let's pretend you have a kid who wants to play with some cars on different tracks, and the tracks are scattered, right? So in order to play with it, the kid has to go to each track, each car, and move it ahead or play with it or whatever. And it takes time because the kid has to move in between each track and find each card stuff. And that's very much like our game object workflow, where your CPU has to load all these objects from memory wherever they happen to be and update them one at a time on this main thread. And it's slow, right? It's kind of slow. And so if we think of this in terms of something like an entity component system, it's like, say, taking the same kit, the same cars, but putting them all next to each other on the same track. So the kid still has to go and move each car one by one, but they're all nice and together, right? It's organized. It's a lot faster for the kid just to go, I'll move one, move one, move one. They're all right there, right? So it's an easier way for the kid, in this case, our CPU, our processor, to digest or update this stuff. Now, let's talk about the job system. Now, let's go back to, okay, you've got the one kid and the cars are on tracks all over the place. Well, the job system's like having multiple kids, right? Each one is able to move or update their car at the same time. They're still scattered in memory, right? But each one can be updated because you're using the multiple threads of your CPU in this instance. And then finally, you have something like the burst compiler, which is akin to giving this kid a bike. It just makes things faster. And we're going to see this in the editor. It's actually really, really cool. Now, a lot of times people are thinking, well, I need to make a dots project, or I need to make a traditional like game objects project or object-oriented project or things like that. The realities are is most projects are going to likely have some combination. You're going to have maybe some dots and some non-dots. Some things are going to be jobs that are created inside ECS. There's going to be jobs that are created in mono behavior code. Some code's going to be bursted, right? It's all about finding the right tools and the right methodologies to solve the problems that you're facing, right? So to think like I have to make a completely, you know, dots game, you don't, right? So there's just it's about solving problems really, and that's kind of this hybrid solution where you're going to apply dots where it makes sense for you and your project. Cool. All right, man, a lot of Q&A questions already, so hopefully the folks in the chat are getting to those. I'm for the sake of time, I'm not going to sit here and read through all the Q&A. Other folks will be answering those. We'll probably get to some at the end, but like I said, a week from today on our live stream, it's gonna be a great Q&A live stream on Twitch and YouTube Live, so definitely check that out. All right, so I talked about the different parts of DOTS, the data-oriented technology stack, and one of them is this ECS, Entity Component System. And this one is a little weird. We know Burst makes things fast. Cool. The job system lets you just run multi-threaded code, things across the different threads. That's pretty easy to understand. But ECS tends to be one of those things that's a bit mysterious, right? Because it's a very different way of thinking about your data and your functionality from what you kind of learn in school. All right. So let's look at a mono behavior. And in a mono behavior, you have data and functionality coupled very tightly together, right? So you might have one script that's going to have a transform, speed, health as data. It might have some method to move things, some method to take damage. They're all kind of together. And if you had a bunch of different mono behaviors, they might have duplicated data. They might have duplicated code. Maybe they both have moves things. And then you have to get into things like inheritance or implementing interfaces, or, you know, it can get kind of messy because of how coupled they are. I mean, it works, obviously. But when we're talking about higher performance with our CPUs and making things a little bit more digestible to our CPUs, we want to look kind of at a different way. And this other way is this concept of an entity component system, which has three things in it: entities, components, and systems, right? So an entity itself doesn't really contain data. It's mostly just an ID we use to find data. But then you have these data components. So in this case, I might have a transform data component as its own thing. I might have a speed data component as its own thing. I might have a health data component as its own thing. And entities are comprised of unique combinations of these data components. They have no functionality on them, though. They're just data. And then you have systems. Systems basically query for data and do something to it, right? They're like processors. Like, find me all the things that have this, and then I'm going to do that to it and then put it back, right? Systems don't know about, you know, the different types of entity kind of concepts, right? It's just saying, give me data, do something to data, put it back. Easy peasy, right? And so it's just kind of a different way of breaking these things apart. Some of the chat said, great explanation. Thanks, Juan. I appreciate that. Okay, so the nice thing about this, even though it's a little conceptually more difficult, is that we can share data components, you know, like types. So like an enemy might have a transform data component, a speed data component, and then a health, which might be unique. And then a bullet might have a transform data component and a speed data component. No reason to rewrite those. They all kind of contain the same thing. And then maybe in the case of a bullet, it damage. And then again, our systems use these in unique ways. Like the move system might say, give me any entity or any data that is both a transform and speed, and it finds both the enemies and the bullets. The move system doesn't know that they're entities or bullets. It just says, you have a position, you have a speed, I'm going to move you. Easy enough. Or you have something like a take damage system or a damage system that's going to say, well, you have a bullet and you have an enemy, and let's assume they're colliding. Well, I'm just going to take the damage from the bullet and subtract from the health of the enemy. But it's not even saying bullet enemy. It's saying find the damage things, find the health things and let's subtract them, right? It doesn't understand this concept of, enemies, players, bullets, whatever. It just sees pieces of data. And the nice thing here as well is these systems can do this fast, even if they're not burst, even if they're not jobs, you can do them fast because these entities or this data, these archetypes, these unique collections of data components are stored all tightly packed together in chunks of memory. So when it's time to, say, move enemies, it could just grab the whole chunk and move them all at once. And bullets, grab the whole chunk and move them all at once. So that makes things, fast and easy and whatnot. And hopefully that explanation was good. I'm trying to get through this kind of quickly here because I would really like to get into the demo itself. And so with that being said, let's get into the demo. So here we go. And I'm just checking chat real quick here, making sure there's not anything major that I'm missing or anything on fire. Uh, cool. Let's see here. Most of these should be answerable by folks. Is Dots compatible with Apple Vision Pro? Absolutely. What are the advantages of Dots? I feel like I just covered that, so let me know if I didn't. And so on. Quite a few other ones, but let's get into it. Okay. So here I have a project, right? And I've got this character, and there's some stuff obviously already existing in here. And if I hit play, what you're gonna see is my character is going to run around, or it's gonna try to run around. There we go. Okay, sorry, I had to move my webinar stuff out of the way. So my character is going to run around and I can shoot some bullets and I can see the bullets over here and everything is great. And if I open a profiler, it's reasonable. I'm running well above 60 frames a second. Nothing's too crazy, right? And so if this were my game, right, hypothetically, I'd have no real reason to implement dots because everything's fine, right? I've no reason to go crazy with this because I don't really have a problem. And I think a lot of times people try to implement some of these optimizations and tools just because they want to or because they feel like they have to. And I think it's important to understand that, yeah, you could, but you're not really solving a problem, And so it's good to understand your problem scope, before you try creating solutions. So let's create a problem. All right. So let's say for whatever reason, I need to fire bullets, not in this sort of straight line, but I need to fire bullets as a spread shot. So I have this checkbox here on my player shooting script called spread shot. It's going to create a 20 by 20 grid of bullets 10 times a second. So 400 bullets 10 times a second. Now, I'm sure you can imagine how this is going to go, right? So it's going to be very, very slow, right? And, oh, so there we go. So you can see it spikes to less than 15 frames a second, incredibly slow. And all the fans on my computer have just spun up. And it's like, what the hell are you doing? Okay. Now, for those of you who are more cynical in the audience, you're saying, well, this is dumb. You're creating a bunch of bullets, you're destroying a bunch of bullets. Of course, it's going to be slow. You should be object pooling. You could use particle. There's like so many optimizations that I could do that aren't dots. And you're absolutely correct, right? This is just an example, right? And the thing is that those optimizations, object pooling and things like that, also work with entities, right? So I could use the same optimizations, make entities even faster. So it's just because I can apply those optimizations to both, I'm just trying to compare apples to apples, right? Just I'm going to create and destroy a bunch of game objects. I'm going to create and destroy a bunch of entities to show you the speed performances and to show you how, right? Let's not get caught up on that. Well, this isn't a great example because you're absolutely correct. And there are a lot of things. As someone in chat just said, can you do pooling with ECS? Absolutely, you can do pooling with ECS. There's no reason you couldn't. Okay, let's begin solving our problem. So the first thing is I want to ensure that I have dots installed. So I'm going to go to my window and package manager, and I'm looking at the packages in my project instead of the whole registry because I already have them installed. And so you can see I have burst installed here. I have entities, graphics, and mathematics. And so those are the things that are already installed. And so I'm good to go here. And I can see I have this new jobs menu with burst. And right now compilation for burst is off because I just want to kind of work this way so far. Cool. So now I have that. And it's also important to note that I have some scripts already written. So obviously there's the mono behavior, the game object scripts that I already have written, but I also have, some of these conversion scripts and data scripts and systems already written because we just don't have a ton of time, but we're going to write some code too. So don't worry. And I'm going to explain kind of what's going on in here. All right. But the first things first is I want to shoot some bullets, right? And I want to bypass this problem that I have. So in order to convert a game object into an entity, I want to go through a process called baking, where it is baked from a game object into an entity. And there's a few ways I can do this, but the simplest way is using the traditional or the standard baking workflows in my scene. So I can go to my hierarchy and hit this little plus icon, and I can add a new sub scene. It's just going to be an empty scene here. It's going to ask me what I want to name it. And yeah, I'm just going to name it new sub scene because why not? So cool. I have a sub scene. And now, if I just drag my bullet prefab into my new subscene, like so, it will bake. And the nice thing here is I can actually see a preview of the entity this is going to create. And you might be thinking, well, what are all these data components? Right? Well, these are data components that Unity recognizes because of a transform, because of like the mesh filters and mesh renderers. And these are all the things that, you just sort of use um, or that Unity recognizes and converts for us. Someone asked why I'm not using dark mode. I find some people have a hard time seeing dark mode in a webinar or in a video, so I put it into light mode so that they don't have that problem. So there you go. So basically, these are the components that Unity understands and knows about. And if I hit play, you will see that my bullet is there, just chilling. Nice bullet, just hanging out, right? Because it's been converted to an entity, but all Unity knows what to do with that is to give it some rendering information, and it just sits there. It's nice. It's a cool entity. It's not particularly useful. So let's make it a little bit more useful. So if I look at my bullet, here, I can see that, again, Unity knows what to do with mesh filters and mesh renderers and materials and rigid bodies and transforms, but it doesn't know what to do with this behavior script, this projectile behavior script that I wrote. Well, Unity has no idea what to do with that. And it has these members on it, speed and lifetime. And again, Unity doesn't know what to do with that. And so I need to tell Unity what to do to that. And I'm going to do that using something called authoring. And one of the things I have in here, I have this data folder in my scripts is called shared data components. These are data components. Remember ECS, entity component data. These are the components that I've already written. And you can see here is one data component. It's always a public struct, name of the struct, and then I component data. And our standards are that if it, only has one piece of data in it, we just tend to call that data value. If it has multiple pieces of data in it, then it has, unique names. But so this one would represent something's health. We have a move speed. This represents something's speed. Time to live represents how long something lives. Then we have these tags, right? Again, they're just iComponent data. We call them tags because there's no data inside them, right? If something has them, it's purely for identification, right? Just like a tag, right? It doesn't do anything. It just helps you, find it, right? Which is important. Cool. And so those already exist. And now I'm going to go ahead and I'm going to add a script to my bullet. And I'm going to come down here to scripts, dots, conversion. And I'm going to drag this projectile authoring script onto it. And I'm going to open this up here. Now, the projectile authoring script, it exists, but I've removed all the code so that we can write it here. And if you get this from GitHub, all the code will be there, so don't worry about that. And so what I'm going to do is I'm just going to write some code here. So this is a mono behavior. It's going on a game object. This bullet prefab is a game object for now, and we're going to tell Unity how to convert it. And so the first thing I want to do is I'm going to create a class inside this. I don't have to put it inside, but it's nice and organized that way. So it's going to be a public class, and I'm just going to call this projectile baker, and its type is going to be a baker. All right, and the baker type will be projectile authoring, the same as our mono behavior here, right? So that is our class. And this is going to have a singular method, and that singular method is, oh, I didn't mean to do that. I was just trying to get it to auto implement the class for me. Bam. And it's going to have a single method called bake. And so this is where I am going to put the code that's going to tell Unity how to convert one thing into the other. So the first thing is I want to get access to my projectile behavior. Ooh, there we go. Live coding. And we're just going to use the syntax of authoring, right? Which is that thing that's read in here. Authoring is going to give us access to this authoring mono behavior here and the things that it has in it. And I'm going to say get component or classic get component. And I'm going to be looking for the projectile uh, behavior. There we go. So that's going to give me access to my projectile behavior. And then I'm going to say var entity equals get entity. So this is going to create a brand new entity for me. Get entity is a part of the Baker class. I can just do that and it's going to create an entity and give it to me. It's going to be empty or blank or, whatever, but no data yet. And I need to tell it what our transform usage flags are. And I have a few options here. I can do something like dynamic, none, non-uniform scale, renderable world space. I'm going to do dynamic. And what dynamic means is this is an object, or not an object. I'm going to say that a lot, but this is an entity that is going to move and it's going to be rendered. And so that it's going to have the types of data components that allows it to be rendered and allows it to move around in 3D space. Cool. And so there's that. And I'm going to add a component to this. So I'm going to add a component to my entity, and that is going to be entity. That is the entity I'm putting it on. And I'm going to give it a new, and I'm going to give it a time to live component, which is in those shared components I showed you earlier. A new time to live component, and inside here, value is going to equal my projectile behavior dot lifetime. That's the value that you saw on that mono behavior that lives on the bullet. I'm just taking that one and putting it into a data component version for myself. And let me just copy that. And I'm also going to give this a move speed. All right. And that's also going to come from the projectile behavior. And this time it's just going to be called speed. And then last one, I'm going to add a component to this, again, to entity. And this one is going to be a new move forward. Now, move forward is just a tag that says, hey, this thing moves forward. That's bullet. And that way I have a system called move forward that's going to look for things that are tagged to move forward, and that will make it go. I'm going to go ahead and hit play here, and we're going to see what's going to happen once that finishes compiling. And just going to hit play. And we're going to see that that bullet goes and just flies off. Okay, that's cool. The bullet moved. Why did it move? Well, it moved because I have a move forward system, which we're going to take a look at in a second. But it's also not very useful. It was one bullet that flew off into space, and that's not all that helpful. We want to create a bunch of bullets, right? So this isn't so particularly good. So what I'm going to do is I am going to remove this bullet from here. But before I do that, look at this. This is pretty cool. If I look in my inspector, before I showed you that entity baking preview, and now I can see there's move forward, move speed, time to live. So you need like, cool, I'm going to bake this. I'm going to know what these things become. And there we go. All right. So now it knows. And so I'm going to go ahead and I'm just going to apply that change this prefab, and I'm going to delete this prefab from there. All right. And so instead, what I want to do is I want to create a way to find this bullet in my mono behavior that's going to shoot these things. And so I'm just going to go ahead in my subscene. I'm going to create a new game object that will become an entity. I'm going to right click. I'm going to go to game object, and I'm just going to create an empty, which I'm going to call directory. There we go. And so with our directory here, I'm going to drag a script called directory authoring, which let's just take a quick look, is not anything special here. It is similar. It's going to be directory authoring. It is going to have two game object references. That's going to be our bullet prefab and our entity prefab that we want to convert into entities. We're going to have a Baker class in here. And our bake method, we're going to get an entity. This time, the transform usage flag is going to be none because this is an entity that does not move and does not render. It is just kind of a lookup if you want. And then we're going to add a component called directory. And that component is defined right down here. This data component is directory, iComponent data with two pieces of data. Both of them are entities of what I'm calling bullet prefab and enemy prefab. Now, I could have put this data in the shared components, right, with all the other ones. I mostly put this here just to show you that you can, right? It doesn't have to be in this shared data components script or whatever. A lot of times people want to put their data components with the systems or the things that use them. Other people prefer to keep them all centralized. It doesn't really matter. It's all about how you want to organize your project. But in here, I'm going to say in my add component method inside the bake that my bullet prefab, this entity, is going to equal get entity. And this time I'm going to pass in this bullet prefab and transform usage flags dynamic. And so what's neat here is with the projectile authoring, get entity just gave us an empty entity. But if we pass something into get entity, Unity was going to bake it or convert it for us. And so you can see that this thing, when it bakes, will bake the next thing, which would bake the next thing, which would bake the next thing. And you can create this sort of chain of things baking. Someone said, is directory a horrible naming convention? It might be. I just picked it. Sorry, because it's a directory. I'm going to look something up. I don't know. It made sense to me. So there we go. So this is going to bake our prefabs for us. And so on directory, I'm just going to drag onto it, bullet into the bullet prefab there, and enemy on the enemy prefab there. And that is going to handle converting. Now, if I hit play, we're not going to see anything because now the bullet isn't in my scene, right? It's being baked behind the scenes by directory and its baking method. Now it's time for me to actually make this fire off through code. So I'm going to open up my player shooting script. Okay. Now, inside my player shooting script, most of this is just mono behavior code that works with game objects and things like that. And then I do have two variables that I've already written in here just to save time, an entity manager that so far isn't assigned to, and a bullet entity prefab, which again, isn't that assigned to. Inside my start, I say, hey, if I'm not using ECS, just leave, because why do we need to be in here if we're not using ECS? Let's say we are. Well, first thing I want to do is I want to get my entity manager. My entity manager is sort of like my window into the entity world through mono behavior. So I'm going to say manager equals, and then I'm going to say world dot default game object injection world. That's the world that things are injected to by default. And then entity manager. Give me an entity manager default game object injection world. Now, the manager is great, but I also need a query. We work with queries a lot. Queries are ways to look up data, and I need a query that's going to find my directory. All right, so I'm going to create an entity query. There we go, which I'm just going to call query. And I'm going to make that equal to, I'm just doing this new line because it's a longer one, a new entity query builder. All right. And I'm going to give it an allocator.temporary. So allocator.temp is a temporary query. I'm not going to keep this around forever. And then I need to tell it, well, what does this query need to have? And so I need it to find with all directory. There we go. And then dot build. And I need to pass in the entity manager that I want to utilize. So this is basically a long way of saying, hey, create a query. This query doesn't live forever. It's got to find every entity that has directory, right? In case there's only, in this case, there's only one. It's going to build that one. And so that query just sits there now. It's ready to go, but we haven't used it yet. So now I'm going to use it. I'm going to say, hey, query, do you have or has singleton directory? Now in this case, I'm just going to use it as a singleton. Now, this is not the singleton you might be thinking of, like game object singleton. This is us just saying, hey, there's only one of these entities in existence. It makes it really easy to find and use. If there's ever less than one or more than one, I'm going to get an error, but it's just a nice, simple way to access this. So I'm going to say directory, if there is one, cool, then I'm going to say bullet entity prefab is going to equal, hey, query, all right, this time I want you to get the singleton, not just tell me if it exists, directory. There we go. And I'm going to find on that data bullet prefab. So directory, grab me your bullet prefab, and very, very easy there. I've started a flame war in chat about whether or not directory is a good name or not. Apologies. It is just an example. I'm not claiming that that name is a perfect name by any stretch of the word. But cool. So there we go. So this basically is all the work that gives us a manager, which we're going to continue needing, and the entity that we're going to need to make copies of. So now I'm going to scroll down to spawn bullet. All right. And this is where I do the actual spawning work. I'm just going to create an entity, which I'm just going to call bullet. And I'm going to do that by saying, hey, manager, I want you to instantiate something for me. And I want you to instantiate a bullet entity prefab, just like so. And so it's going to make a copy of this entity that we baked. And it's going to create one with all the same data components and all that cool stuff. And so once I've done that, that bullet would generate and just go flying off, but I need it to actually appear at the gun barrel where I'm shooting the bullet. So I got to create a new local transform component, which I'll just call T equals new local transform, like so. And I just need to give this a position, rotation, and scale. So position is going to equal the gun barrel dot position. There we go. And then my rotation is going to equal quaternion. Everyone loves quaternions. Euler. And I'm going to pass in this rotation that was passed into this method. That's the rotation of the gun. And then finally, scale is just going to equal 1F, right? So just normal scale. And now I just need to, nope, can't do the semicolon again. Now I just need to put this data component or associate this data component with this entity. So I'm going to say, hey, manager, I want you to set component data like so. And I'm going to set it on my bullet entity like so. And so now this bullet will get this new transform and have that position and everything. So back in Unity, gonna let that finish loading up there. And I'm gonna scroll down. I'm gonna uncheck spread shot for now because I haven't implemented that, but I am gonna check use ECS and I'm gonna hit play. There we go. Now I'm firing bullets, and I know I'm firing entities because I'm not seeing them here in the inspector or the hierarchy view. I'm sorry. These are entity bullets. They're all flying forward again because I have that move forward system in place. And if I want to see these entities, I could go to Window, Entities, and Hierarchy. And now I can see the entities spawning here, being instantiated here. However, I will call out this window is not particularly efficient when you're making a lot of changes. It can really slow your editor down if you're doing a lot of stuff with entities. So I tend to keep it closed unless I'm actively debugging something. So there you go. Okay. So I haven't really solved my problem yet. All this work was just to get to a point where I could just do what I was able to do before, create bullets, right? Now I want to create a lot of bullets. So I'm going to go back to our player shooting script, and I'm going to come down here to this spawn bullets spread ECS. By the way, I'm going to call out that spawning these bullets as entities is not actually much more difficult than spawning them as game objects. So with a game object, you instantiate whatever a game object, you have it some position, some rotation, right? Now the extra bit here, we're setting that. But if I go up to just spawn bullets, it's nice because we have it as a singular method. But again, we're instantiating a prefab, giving it a position and rotation. So it's a little bit more syntax, but the concept of it is exactly the same. And now let's spawn a bunch of them. So I have my spawn bullet spread ECS, and most of this is just like rotational code that makes me have that nice grid. So what I would like to do is I would like to just do the entities bits. So I want to create a bunch of these at once. And a nice way I can do that with a nice collection is using something called a native array, which is a collection that's great for using with dots. It's thread safe, it's efficient, it's super cool. The one downside of a native array versus like say a list or other managed type of collection is that you have to clean it up or you get a memory leak. So I'm going to make sure I do that. But I'm going to create a native array of type entity, which I'm just going to call bullets. All right. And then that's going to be equal to a new native array. And I need to say, well, what's the capacity of this thing? And so I'm going to tell it that the capacity here is total amount, right? Which is something calculated up here. And also what is my allocator? So allocator.temp, because it's not going to persist. I'm going to use it for a little bit and I'm going to get rid of it and I'm going to get rid of it myself. All right. And then I'm going to say manager, right? Remember the manager dot instantiate. And in this case, I'm going to instantiate that bullet entity prefab like I did last time. But now I'm also going to pass in bullets. And the nice thing about this is it is going to instantiate however many bullets this native array has capacity for and put them all in this array. So it's just an easy way to create a bunch of bullets all at once. And so there we go. Before I write any more code down inside here, I'm going to go all the way to where I'm done using this, just so I don't forget, because I always forget. I'm going to do bullets.dispose when I'm done using this native array, because otherwise I'm going to have a memory leak and I'm going to be like, oh, why is that? So it's always just good to do my cleanup there. Cool. And so inside here is where I'm, again, just doing the code that's important to me. I'm going to come back up here and actually just grab what I did for spawn bullets, and I'm going to drop it in the spawns spread shot bullets or whatever. So inside here, we have our transform T, new local transform, still have the gun barrel. Instead of rotation, we're going to do temp rotation, which is just something I calculate in here. And then instead of setting that component on bullet, it's going to be on bullets sub index. So we're just going to iterate through this native array of bullets and give them the right rotation so they flare out and whatnot. Fantastic. Okay. So someone said, can you use using on the native array? Yes, you can. I didn't in this case, but yes, you absolutely can. Okay, so I'm gonna go to my player. I'm gonna go to use ECS spread shot. I'm gonna check that. And remember, this is 20 by 20, 10 times a second. That dropped us to around 15 frames a second or a little lower before. So let's see what it looks like now. All right, so cool. Doing great. So let's try, I don't know, 900 bullets, 10 times a second. All right, still above 60 frames a second. Let's try 900 bullets 100 times a second. All right. So that's going to slow us down. So, okay, 900 bullets 100 times a second bring me to a little above 15 frames a second. My fans are going nuts on my computer again. But here's the really cool thing. All right. So I'm going to scroll down here. I'm going to set this. What were we at? 900 bullets 100 times a second. Now I'm going to turn on burst. And the nice thing is I don't have to do anything special with my code. Just by virtue of turning this on, bam, enable compilation, burst is activated. Let's do this. So now I'm going to hit play and let's see. So 900, 100 times a second. Sure, why not? That's well over that. 1600 bullets, 100 times a second. Okay. 2,500 bullets. Sure. 3,600 bullets, 100 times a second. 3,600 bullets is, what is that? 360,000 bullets a second. Sure. Right. I think that one puts us kind of at 60 frames a second with some spikes in there, but that's grossly more than we could ever possibly need. So you can see here, just, yeah, it's dumb, but really, really fast. So let's make this a little bit more reasonable. So I'm going to drop this back down to like 40 by 40, 100 times a second, because now we want this game to be kind of challenging, right? So let's turn on some enemies. So I'm going to go to my enemy spawner, and enemy spawner has been turned off this whole time, but it's actually set up exactly like the player shooting, right? It is, instead of creating bullets, it is creating entity enemies, right? And these are going to spawn. So I just turn that on there. I'm not going to show that code because it's the exact same thing. And then I'm going to hit play. Let's see here. So there's an enemy and burp. Okay, so I'm fighting these enemies and okay, so maybe the game isn't super duper challenging, but I do have a problem here. The enemies aren't chasing me. They're just moving forward, and that's really, really boring. So this is where we're going to write our first system. We are going to make the enemies chase the player. Cool. Someone in the Q&A said our conversion data system folders standard in terms of names. No, I just picked those. You could kind of choose whatever organizational structure for your code that you want. All right, so let's make the enemies turn towards us. So I'm going to go to my systems folder here, and I'm going to open up my turn towards player system. And again, most of the code has been removed. I do have this thing called burst compile at the top here. I have this partial struct called turn towards player system, which is an I system. We're going to kind of get into that a bit. And I've got some code down here. So I can create a system, as part of entity component system, whatever, that just does the work that, it wants to do. Or I could have a system schedule a job, right? That will allow that code or that work to be done off of the main thread, either in a singular thread or multi-threaded. And that's the route I'm going to go. I'm going to use this system to schedule a job to do some work. All right. So let me just come down here. I'm going to create the job first, and then I'm going to schedule it in my system. So I'm going to come down here, and I'm going to go ahead and create a job. And so what I want to do is I want to create a public partial struct, and this is going to be the turn toward target job. All right. And that is going to be, it's going to be an iJob entity, but I just wanted to stop here to say, okay, you have iJobs, you have iJob chunks, you have iJob entities, you have iJobs for, iJob parallel for. There's a lot of options, right? Each have their own pros and cons as to why they're structured a certain way. Some of the other systems and jobs in this project are different. You can go check those out. I'm just going to go ahead and do an iJob entity because it's a nice, simple syntax, right? It gets turned into an iJob chunk behind the scenes, but the syntax for me, it's a little bit easier to write. And so that makes things pretty cool. Now, if I want this to be burst compiled, which I do, I'm going to come above my job here and I'm going to add the attribute burst compile. And I'm going to get in a moment. I'm going to get into why you may or may not want that on some things because we're not going to burst compile something here in a moment. But I'm going to burst compile this job for sure. And then I need to give it, there's going to be something, this turns things towards a target. So I need to know what my target is. I'm going to create a public float 3. It's going to represent a position. And I'm going to call this my target position. And then inside here, I need void execute. Execute is where the work is done. And so I think about jobs and I think about systems is they work on data, but they need to find the data they need to work on. So they need a query, right? They need a way to find the thing that they need to work on. So I could pass a query into a job when I'm scheduling it, certainly. One of the nice things about iJobEntity as a syntax is I could provide the query as a part of the execute method, as a part of the parameters, and that just becomes the query, which is nice. And so I'm going to do that. I'm going to say ref, all right. Oh, no, that is not ref. Ref, and then I'm going to say local transform, which I'm just going to call transform. So the query, it's going to query a few things with a local transform. And then inside the execute method, I'm just going to grab this. I didn't feel like typing this all out. This is just math. Basically, it's saying we're going to calculate a heading by taking our target position and subtracting from that our current position, removing the y so it doesn't move up and down, it only moves flat. And then we're just going to create a rotation to look at that spot. So I didn't feel like typing that all out. But there you go. And so, yeah, so there we go. And the nice thing is execute is going to run one time for every entity that matches this query, right? And then that's my job. I'm going to go up to my system now and I'm going to use this job. So again, I have burst compile, but then I also have a little note to myself here that I'm going to add some timing to this. I want the turn towards target or the turn towards player system to update before, all right? And I'm going to say type of, and then I'm going to say the move forward system. Move forward system is real simple, just finds things that need to move forward and moves them forward, right? That's why we put that tag, move forward on the bullets, and system just goes, cool, let's just move them forward, right? But I want to update this before they move forward. So I want the enemies to look at the player and then move, not move and then look at the player, right? Which would be, one frame behind. So I just want to ensure that. And so inside here, on create, I want on create to burst compile because why not? Sure. So I'm just going to tell it that, though you don't really need to because it only does one thing. On create just has a state, which is the system state dot require for update. Oops. So require for update. There we go. Just need to learn to type. Enemy. Man. See, I start typing wrong and there we go. I start going too fast. So basically this is just saying don't update if there are no enemies. The enemies turn towards the player. You don't have any enemies, then this system does not need to do anything. So that's easy. Now, I could say burst compile on update, but I'm about to write some code that is not going to be burst compilable, and I'm doing this on purpose. So if I did put the burst compile attribute on here with burst compilation turned on in the editor, I would get an error saying, hey, you're trying to burst compile this, and it's not burstable, right? So I'm not going to write that. And I'm going to show you what I'm doing that is making this non-burst compilable. So in here, I'm going to say if settings dot is player dead. All right, so the player's dead. There's no reason to turn towards the player. Right, makes sense. Because my system is accessing managed data in this settings class. Settings is just a singleton that just holds some variables for me and things like that. In this case, it's responsible for telling things, hey, is the player dead? Because I'm accessing that, it's not burstable, right? And so I can't, put that attribute on there and it's not going to run crazy fast. Now, there are a lot of ways I could solve this. There's a lot of ways I could get this data without accessing the settings class and thus allow this to be burst compiled. I'm doing this on purpose because there's an important takeaway here. On update can't be burst compiled because I'm doing this. However, on update doesn't really do anything except schedule a job. That's it. Because it only schedules a job, I don't care if it's burst compiled or not, because it's not taking up any time, right? It's nice and easy. So I need my job to be burst compiled for sure, because my job is going to run a bunch of times across a bunch of different entities. But on update, it's going to run one time a frame and it's just going to schedule a job. I don't care if this burst compiles or not. So the takeaway here is, you don't always have to burst compile everything. A lot of times there's reasons you can't. And in this situation, it doesn't even matter because, if on update was actually itself on the main thread, looping through all the entities and turning them, then absolutely I would need that to be burst compiled. But since I'm offloading that work anyway, and I'm merely passing in the position of the player, it's not going to matter. So I'm not going to burst compile it. There's no reason to create a bunch of headache when I don't need to. By the way, this is commented in the repo right inside the code because I'm actually storing the player's position in an entity in another for another reason, which again I call out in the commenting just to kind of, again show you the two ways to do it. So don't be like you have to do it this way. This is not a best practices moment. This is a learning lesson moment. So there we go. So now what I'm going to do is I'm going to go ahead and create this job. So I'm going to say var turn towards target job equals new. All right, turn towards target job. There we go. And this requires a single piece of data, which is going to be the target position. And that target position is going to be equal to settings dot player position. Again, grabbing settings dot player position prevents this from being burst compiled. Again, I'm accessing managed non-static constant data, so it freaks out about that. Not going to matter. So that creates my job, and now I need to schedule it. So I'm going to say, turn, I should have given this a much shorter name. Turn towards target job dot, let's see here. There we go. Now I could do run, and run would run this right now here on the main thread. I don't want to do that. So I could do schedule, and schedule is going to schedule it to run off of the main thread, but I'm going to schedule parallel. And schedule parallel is going to run this as a multi-threaded job off of the main thread. So it's going to schedule it to be run on all these threads, and it's going to do its work, and then it's going to come back and everything's going to be great. And that's our system. Our system here, very simple, mostly burst compiled, all right? Just requiring an enemy to exist for it to run. Inside on update, it is checking, is the player dead, yes or no? Then let's create a job. Let's schedule it to run. That job's execute runs one time for every entity that matches the query. And that's that, right? So let's go ahead and see this in action. Now I'm going to warn you, this isn't going to work. So let's take a look. Well, it's going to work, but it's not really going to work. So I'm going to go ahead and hit play. And now our enemies are chasing us. Great, but here's the problem. So are my bullets. And while that's neat, like I can just sort of create this aura of death around me. It's not what I was going, oh, then I died. Oh, wow. Okay, so the problem is this, and this happens a lot. Our queries aren't specific enough, right? So in this case, my query is about as generic as it can possibly be. I'm saying find every entity with a local transform. That includes bullets, enemies, player, like anything that has a local transform, which is a problem, right? So I need to refine my query a little bit. I could pass in here that it's also has to be, an enemy tag, right? And that's not exactly how you would write that, but I don't want to query I don't want to have access to the enemy tag because there's no data on it. There's no purpose to doing that. So instead, I'm actually going to add this as an attribute. And that attribute up here is called with all, and it's going to be type of, and then that type is enemy tag. So let's only apply this to enemies that have the local transform. All right. And so let's go back to Unity now, and we'll see this working. And one of the other things I want to call out, because we're kind of getting near the end of this demonstration, near the end of our time here, and I'll leave time to answer some questions and stuff, is there's a lot of things that we can use dots for, right? Obviously, there's a lot of optimizations. We can find a lot of performance improvements. Now, in this case, I'm using this to add more stuff. However, you don't have to use it that way. You can have optimization purely for optimization's sake, to give yourself a bigger budget for other things, to use less battery on mobile devices, to generate less heat, right? You don't have to add a ton of things. Now, in this example, we're going to add a ton of things because that's fun. But I do want to call out that sometimes you can just have the optimization and the cushion there. Um, Another thing I want to call out is this. There's a part here that I'm going to show you that is incredibly inefficient. It's done that way intentionally. It's my collision system. So my collision system, I even have warnings like, dude, don't use this. This code is inefficient. Don't do this. If you want good collision code, use, dots physics, another performance solution, write something performant. What this collision system does that I'm using is every bullet checks itself for collision against every single enemy every frame, and every enemy checks itself for collision against the player every frame, regardless of where they're at or anything like that. So it's insanely inefficient in terms of a collision system. All right. I'm just showing you this because I want to show you how fast even terrible code like this can run. Right. If you need it to. It's also a really interesting system because it has like 3 queries in it and it schedules 2 jobs, one and then the next one. Again, fully commented. Check it out. It's pretty neat. Just don't actually use the collision detection part of it because it is a terrible way to do collision detection, right? You want to do something that's a little smarter than that. But I'm gonna go to my enemy spawner, and instead of spawning one enemy at a time, let's spawn like, I don't know, 40, and let's spawn 40 every like half a second. Um, that works. And we want, let's do, I don't know. This would probably be okay. 2,500 bullets 100 times a second against a whole bunch of enemies. Let's see what happens. They're all going to be chasing my player now. My bullets are going to fly out. We let them get close and okay. So pretty good, I would say. Like I said, even super inefficient code still runs above 60 frames a second with an absurd number of bullets and enemies and all this stuff. I mean, it's dumb. Um, Obviously, I wouldn't make a game like this. It's fun, but the realities are is you don't need to do all this. Like I said, sometimes you can just have performance for performance sake. Okay, so that's a lot of stuff. We've got a lot of questions. The chat has been going nuts. Let's sort of kind of hop back into wrapping some things up and answering some questions here because we're just about at time. Um, so first and foremost, if you want to learn more, if you want more, right? Screenshot this slide, right? So you'll find the link to the demo project at the top here. You remember we're doing the Dots Q&A live stream a week from today on Twitch and YouTube Live. We've got on Unity Learn a Dots Basics course. We've got a Dots Boot Camp that we had done last month or the month before. There's a whole reading list of cool stuff. We're going to be releasing an ebook soon. Our ebooks are really, really cool. So that's a pre-registration link for it. Definitely check that out because it's got some good stuff in it. We also offer pro training if you want to check that out. We've got more webinars coming up, later next week and everything like that. And with that, I'm going to say thank you to everybody here. And I'm going to take a moment here to check through chat to check out questions. And yeah, let's see what we can find here. So we have so many questions. Oh my goodness. All right. I'm just going to kind of let's see here. Are the slides shared later too? So they'll be a part of the video when we share the video. Though if you need the slides, message me on Mike at Unity and we can figure that out. But they're going to be in the video. Then this drives bullet motion update by update. But what if we want to use physics? What if we want to use tween shader properties? Can this be handled by dots too? Absolutely. I just created a very simple solution. It's going to move everything. It's creating them. It's destroying them. There's obviously a way more important or better ways to do a lot of this stuff. I just wanted to use just a completely basic explanation or a comparison of game objects versus dots and to show you how. So yes, you could do this through physics and stuff, and that'd be really good to do it. Let's see here. Wouldn't it be more in the spirit of modularity to have a separate tag for anything that's meant to rotate towards the player instead of absolutely. So that's a great question, Cody. I broke my own rule with that system because it's like turn towards player system. And I'm like, but what if you don't want to turn towards player? What if you just want to turn towards something? And it's specifically for enemies, but like there might be other things that turn towards the player. So you're absolutely correct. My naming on this one was not particularly great. yeah, you would generally want to keep this to be a little bit more um, general and reusable. Is there a link or something? There's a lot of links, as you can see on the screen there. Hopefully, I don't know what the question was referring to. Let's see here. What else do we have? Is dots good for managing or for servers managing other servers in a game world like WoW? So we do have our dots multiplayer and a lot of our like game server balancing code and stuff like that. So in essence, yes, data oriented approaches are great for things like servers and large worlds and massive amounts of things, as you just saw. I can't speak to what WoW does with their servers or things like that, but yes, server architectures and stuff can benefit from these methodologies. Um, Let's see here. Sorry, there's so many questions. I'm just picking and choosing here for the next couple minutes, and then we'll wrap things up. Let's see here. Is there any significant difference in rendering and or performance between normal game objects and entities, assuming there's no logic attached to them and rendering? So yes, entities are still more performant than game objects, even without behaviors. They're significantly smaller memory footprints. And again, being located together in memory means that they can all be loaded as chunks, even when rendering. So yes, an idle graphical entity and an idle graphical game object, the entity will still be more performant and more efficient to load up and do anything with. Um, let's see here. Uh, Trying to find another one here. There's so many. There's so many. Uh, Someone has says the Angry Bots ECS project opens with a ton of errors in 2023.3.48. So email me. I'm not opening that version. So I'm Mike at Unity. Shoot me an email and yeah, let's figure it out. Um, let's see what else we got. I'm going to do one or two more. Where can I find the ECS roadmap? That's online. And I think we talked a little bit about that at GDC. And I believe that video is also online, though I don't know exactly where off the top of my head. All right. One more here. Is it possible to integrate mono behaviors with dots? If so, how efficient can be? No, so not really. I mean, they're kind of mutually exclusive, as you just saw. Um, that dots uses their own sort of systems and their own sorts of syntax that's different than mono behaviors, which is an important piece of that. So no, they don't really work together. Okay. So let's so many questions. We're capturing these, by the way, and we'll try to answer as many of these as we can next week as well. Thank you all for showing up. Thank you all for sitting through this hour with me and for being all over the world doing this. It's so amazing. I really do appreciate it. Super cool. And yeah, can't wait to see you all next week. Definitely stop on by, send me all your questions. Let's get some answers out there. And let us know if there's anything else. There's going to be a survey at the end of this, so definitely check that survey out. Let us know how we did. Let us know what else we can do better, what other stuff you want to see. And otherwise, I hope you all have a fantastic day and a fantastic week. And I'll catch you later. So cheers, everyone. Take care.